Okay. Hello. I think so. We are live now. Are we live now? Everybody type in the chat box so as to say whether we are live or not. Let's see whether we are live or not. Okay then. Okay, so in just 10 seconds, we would go live. Let's see how it is going. Started. Yeah, hello, everyone. Super excited to be here. I'm Faraz, sir, from Kalam Labs. I think many of you already know me. So super excited to meet all of you and to have this wonderful session with Jarred, sir. Just a short intro about Jarred, sir. Jarred, sir, is an aerospace engineer at NASA. He works at NASA. Can you believe it? Like all of the rockets, all of the spaceships, all of the telescopes, the one organization which makes it. So Jarrett sir works there. So it's going to be super fun to interact with him today. I have a bunch of questions that I want to ask. I'm sure you would also want to ask. So what we are going to do is that if you stay with this session after 40 minutes, we are going to open up the Q&A. After 40 minutes, you could ask any question to Jarrett, sir, ask him whether aliens are real or not, and what is NASA doing so as to find whether aliens are there or not. Every question Jarrett sir is going to ask, going to answer us, and of course the scientific questions as well. So that is what we are focusing towards today. And over to you, Jarrett, sir. I'm sure you must be super excited to meet the Kalam Labs kids today.
Yeah, thank you for us. Yeah, I'm very excited to talk with you all today. So yeah. Would you like me to share my PowerPoint?
Of course. No, okay. So just wanted to talk, Jarrett, sir, as in when did you join NASA?
Yeah, so I joined, it was a little over 4 years ago, full time, but I started as what's called a pathways intern. So I worked a few internships, but even before that, I did a short 10-week program back in 2010. That was at the end of my freshman year of college. And then ever since then, I've been working different internships throughout my undergraduate career. And then after I finished my master's, that's when I started full time.
Okay, got it. Mm-hmm. And Jarrett, so as in, what was your biggest motivation for joining NASA?
Yeah, great question. So as a kid, I was always interested in anything related to space. So I would constantly be reading books about the solar system, the planets, and also anything related to NASA. And here in Cleveland, we have a science center. Well, now it's called the NASA Glenn Visitor Center. And I remember going there as a little kid, and even we went on field trips there, like when I was in grade school. And I just remember always being so fascinated, just drawn to that. And it was really exciting, always fascinating to learn about things like that. And that's how my passion developed for that.
So Jarrett, so like back when you were a kid, right? Like in about 6 to 14 years of age in your grade school. So what was the one science topic which you were most fascinated about?
So coming up in grade school and even high school, I was always interested in math and science, like you said. Pretty much all the science subjects I was drawn to. So freshman year of high school, I took biology. I liked it, but then I loved chemistry. Like I really was drawn to that, learning about the periodic table and different elements. And that was my first exposure to different experiments, and like with the hands-on experiments. And then when I studied physics, it just opened me up to another world. And so I think physics is what I was most passionate about in the sciences.
Great. Yeah, of course, Jared. So, like physics, chemistry, those are the things that we at Kalam Labs are also really passionate about. And so was Harshit sir also, as in who was going to take this session. And as you can see, kids, like today, instead of Harshit sir, me, I'm going to take this session, and he was going to join in next weekend for you guys. And wonderful science topics would be discussed there as well. And as you were talking about the your basic motivations, as in Jared sir, I always had this one question, right? I always had this one question about NASA, which was that right now we have such big computers, a phone, laptops. We could talk to each other through Zoom calls and even go live on YouTube. We have all this technology.
Mhm.
So it is conceivable, it is understandable that we are going out into space. But I want to ask, what was the motivation in 1960s when we had first gone to the moon? We had actually taken a rocket to the moon, which we see in the night sky, and had actually landed there. So how was that possible? What was the energy like that then? Can you share some things, some stories you might have heard, anything which you like to want to share?
Sure, that's a really good question. So, in the 1960s, that was when the space race was really prevalent, and we were competing against the Soviet Union to try and get the first, not only like even before the moon, just to get to space, period. And the Soviet Union actually, they got the first man in orbit with Yuri Gagarin. And then we were next with Alan Shepard and then John Glenn with the Friendship 7. And then it was just a nationwide movement to try and get us to the moon first. John F. Kennedy, he really spearheaded that movement and said we would get there by the end of the 60s. So that was what the Apollo mission was all about. We had support just nationwide from the government and everybody. And that was what the Apollo mission was for. So Apollo 8, that was the first mission. We didn't land astronauts on the moon then, but of course, Apollo 11, that's when we first set footprints on the moon with Neil Armstrong and Buzz Aldrin. And then with we had 5 more Apollo missions where we landed men on the moon. And in 1972, that was when the last Apollo mission was. So,
Wow.
mhm.
Those must be really exciting times indeed to
Yeah.
actually go to the moon. Back when I heard this fact that the computers which were powering the Apollo 11 missions, I think so that's the mission which took Neil Armstrong to the moon, right? If I have it correctly.
Mhm.
So that had the power equivalent to a calculator that we have right
Yes.
now.
Mhm.
So that was the power, but we still reached the moon. So this is incredible.
Yeah, it
So
just shows with a lot of support and a lot of having a large budget behind you, what you can accomplish, and just having that motivation, like from everybody, like from the scientists to the engineers that work tirelessly just to get us to the moon. Anything was pretty much we saw from our standpoint that anything was possible, and yeah.
of course, sir, of course. And we at India also are striving very hard so as to reach into the space. The kids at Kalam Labs, they love science and are really eager to learn from you today. So, sir, you can go to your presentation right now and let's
Okay.
learn a lot about science today. Okay?
Okay. Sounds great.
Sounds good.
Okay. Okay. Can you see my slides?
Yes, so we can.
Okay.
Yeah.
So as Faraz said, I work at NASA Glenn Research Center as an aerospace engineer. And I've already touched on this a little bit, but just a little bit about myself. I was born and raised in Cleveland, Ohio, and I grew up in a family of 4, my mom, dad, and my younger brother. And I was always interested, as I told Faraz, in math and science and anything related to space. So I was always reading books on the solar system, the planets, and of course, anything related to NASA. So where I went to school, I'll just run through this really quickly. So I started at Benedictine High School. So it's all boys college preparatory high school. It's Catholic, and I started going there when I was 14. I graduated as valedictorian in 2009. Then I started attending University of Cincinnati. Um, the campus, as you can imagine, is very large, but I chose to show this picture of what's called our Engineering Research Center because it's a place that's near and dear to my heart because I spent almost every day there as a student. And of course, I studied aerospace engineering while I was there for 7 years for both my bachelor's and master's degrees. And even though I am working at NASA full time, I'm also pursuing my Ph.D. at Case Western Reserve University, which is also in Cleveland. So how I got to NASA. So I touched on this a little bit when I was speaking with Faraz, but in 2010, this was when I worked my first 10-week program over the summer after my freshman year at UC. That's just a picture of me in the lab. In 2012, that was when I worked on my first official NASA project as an official intern. So it was really exciting times. I worked a few different rotations throughout my internship or different internships. 2014, that was when I started graduate school. And this picture was taken in 2015. That was when my wife and we visited the Johnson Space Center in Texas. And this really got me inspired even more to work at NASA someday and to finish graduate school and conduct meaningful research that would contribute to the aerospace community. And in 2016, I graduated with my master's from University of Cincinnati. This is a picture of me with our mascot, the Bearcat. And now I've been at NASA for a little over 4 years now. There's a picture of me on my first day in front of our the hangar. So what I do at NASA. So I do a combination of analysis and experimental work. But what I specialize in is what's called thermal analysis. So that's basically using computer programs to develop models and to design and simulate parts of an aircraft or spacecraft and to determine or figure out what temperature they'll reach while they're in flight. And this for the purposes of performance modeling and design. So what's shown here on the left is a model of the OMS engine nozzle. It was first used on the space shuttle, but it's been refurbished and we're planning to use it for propulsion on the Orion spacecraft, which will take the next man and first woman to the moon. And for experimental work that I've been involved in, I've done thermal vacuum testing, which I'll talk about a little later, and also flow loop testing, which I will do. It's more related to my graduate research that I'll be doing, that I've been working on. So this is just an example of a thermal model that I get to work on every day. So this is what's shown here is a single cell in a stack battery or a VFB. So flow batteries are used to store large amounts of power or energy for electrical grid applications. So for electricity, to provide electrical power. So what this model is showing is you can see the hot spots, which are the red, and the cold spots, which are the blue. So the purpose of thermal modeling is to make sure your components stay within their operating temperature so they don't get too hot and so they're able to perform as intended. So this is just showing the typical cycle of a stacked battery throughout the day. So as I said, this is just one single cell in that battery. In reality, in a whole VFB, you'll have 17 of these stacked together to make up a whole VFB. So now I'm going to talk about my favorite project that I've ever worked on, which is the Orion project. So this is just a artistic depiction of the Orion in space, but this is going, as I said, it's going to send the next man and first woman to the moon, and hopefully it will send astronauts to Mars in the near future. So I got to work on this project when I first started full time. And in 2019, the Orion crew module and the service module, they were delivered to Ohio in this really cool looking aircraft called the Super Guppy. And really because this aircraft is the only aircraft large enough or capable to transport something of this size. So this is just a picture of the Orion spacecraft in our facility, which is an hour away from NASA Glenn. So the conical shape is called the crew module, and that's where the crew will be situated while the spacecraft is in flight. So it can take a crew up to 4 astronauts. And then the service module that holds your propulsion, all the electrical power, and fluid storage. So what we did in the thermal vacuum test, we placed this entire spacecraft within a thermal vacuum chamber. And thermal vacuum chamber is, it's incredibly massive. It's 100 feet in diameter, 122 feet tall. And what we did was we ran a nonstop test for 40 to 45 days and cycled from extremely hot to extremely cold temperatures. And these are temperatures that the spacecraft will see while it's in space. And because it passed the test, it was deemed airworthy or able to fly into space. So, and it was really cool being able to work on a project like this that will send astronauts to the moon and to Mars someday in the near future.
Wow. So this was super interesting. Can you just shift back the slide?
Yep.
This was so interesting. So so how do you create such temperatures? Like you're actually saying that this thing can be the way that humans would be able to go to Mars and actually live there. The
Right.
future of human civilization that will extend to Mars could be made by such inventions. So, sir, like, have you actually like gone out and seen it with your own eyes, this particular great equipments?
Yes, I have actually. I had the privilege to do that. I think right after, it was either right before or right after we tested. Yeah, I got to see it in person. Of course, the solar arrays aren't on the, weren't equipped on the spacecraft, but yeah, I saw the crew module and service module in this setup. So it was really interesting.
This is super interesting, sir. And you are saying that this particular object can withstand pressure, like temperatures very, very cold and very, very hot also. So,
Yes.
so when you say very hot, what do you mean? Like as hot as fire or as hot as the sun?
Yeah, so as hot as the spacecraft will be, like, so when the spacecraft is in space, it'll be exposed to a certain amount of the sun's rays. So that would be about 300 degrees Fahrenheit. So that was what we cycled to. And then when it's not within this direct sunlight, it's going to be very cold. So like negative 250 degrees Fahrenheit. So those were the type of temperatures we cycled to. And I also forgot to mention that we also significantly reduced the pressure. So down to the vacuum, because space is a vacuum. So that was what we reduced the pressure to. So very close to 0 PSI.
Wow.
Yeah.
So basically this can move through space, withstand fire and freezing cold at the same time. So this
Exactly.
is,
yeah.
Wow, this is a great invention. That thank you so much for sharing with us this. Wow, this was really cool. Of course, sir, let's move ahead. I mean, it really excited, really loving this. Please move ahead, sir.
Sure. Yeah. Okay, so now I just want to talk about Glenn Research Center as a whole. So we have over 3,000 employees of all different kinds of disciplines. So all kinds of engineers, different scientists, so like astrophysicists, geologists, biologists, chemists. We have business professionals, IT, so technicians, all kinds of disciplines. And we have over 400 laboratories dedicated to research and development. So we have our drop tower, which we use for microgravity studies. So studying things at nearly or at zero gravity, which is important for things going to space. We have vacuum chambers, like the facility that I just showed, and the Neil Armstrong test facility. That's for our large scale tests, and those are done at those aren't done at Glenn, but they're done at a facility that's about an hour away from NASA Glenn. And we have we're always dedicated to space science and technology developments that will help for future space missions. So space communications and power systems, we're always working on things of that nature, and studying planets like Venus and Mars, of course, and of course our planet that we're on right now, the Earth. And we also have a ton of engineers and scientists working on human exploration missions. So experiments that will be flown on the space station and also the Artemis missions. We have support for everything related to that. We're also heavily involved in aeronautics research. So air breathing propulsion. So anything like a jet engine that takes in air and uses it for propulsion purposes. And we have facilities like wind tunnels, the icing research tunnel, which is actually the largest one in the country. The research aircraft hangar, which I showed in the previous slide. And we have over 50 component facilities, or 50 facilities dedicated to engine components like inlets, nozzles, and compressors.
This is super cool, sir. This is
Yeah.
super cool. I mean, think about it, having an entire building in which you can fly planes, in which you can take the temperatures to freezing cold and like burning hot, and where you are building machines which can go into the space, create the human civilizations in Mars. I mean, this is the best place to work at. I'm like totally sure. And really like looking forward to learning how can kids also search for learning opportunities at NASA, as you were going to share, sir. Would love
Sure, yeah. And I also want to point out, so we're one of 10 centers. So there's 10 centers, different locations across the country. And the most famous ones are, of course, Johnson Space Center and Kennedy Space Center, which is where all the spacecraft fly out of. And you just saw on Friday, we had the Crew Dragon fly out of Cape Canaveral, and it just docked yesterday. So I just wanted to point that out, that there's many other NASA centers to work at. So now I want to talk about opportunities for you all to learn more about NASA. So we have what's called NASA STEM at Home. So nasa.gov/STEM. It's an easy website to remember. I can even put it in the description if that helps. But there's all kind of student activities for all ages. And we have virtual tours available that became more popular after the pandemic happened, just because people aren't able to actually visit in person anymore. And also we have, as I mentioned earlier, we have a visitor center, which is basically our science museum. All the centers, all the NASA centers have visitor centers, as far as I know, which have a bunch of exhibits and things for not just kids, but adults to learn more about NASA and what we're doing. And there's virtual field trips available on these websites. So if you're not able to attend in person, or if your city or state doesn't have access to these, anyone has access virtually. So
wow. Wow.
yeah, and this is a screenshot of the website I was just talking about, NASA STEM at Home. So for grades kindergarten through 4th, there's space to play, so all kinds of games and fun, interactive opportunities to learn about NASA. We have grades 5 through 8, so middle school, out of this world stuff. We have things for high school students, and even down here, there's college and universities. So there's something for everyone on this website. Again, that's nasa.gov/STEM.
Oh, so that is super interesting to learn. As in, could you share more how like a K4 student or a 5 to 8 student could learn more? As in, what exactly should they be learning at this age about NASA, about space? Could you share more on that?
Sure. I would say whatever you're passionate about. So what drew me to, I guess, NASA in the first place was just the stars in the night sky that I looked at. I had a telescope at a young age, so I started learning all about the planets. That's what I was passionate about. But maybe you're more passionate about, I guess, the rockets or the specific NASA missions, which that's what I got into more later. So there's really not one particular thing you have to learn, but just, I guess, start somewhere, whatever you're more interested in.
Mhm. Great, great, great.
Yeah.
That is super interesting to hear, sir. And now, in a short while, we would be beginning the solar system simulator, and that is going to be super interesting. And before that, let's take some questions. So, kids, if you have any questions, post it on the chat box, and we would answer it. Okay? Yeah.
Okay.
Yeah. Just a second.
And then this is just another screenshot showing the same website. So I wanted to show this because they have videos available. So this is a video about the commercial crew program. So we have 2 astronauts that are telling you all about the commercial crew program. Who knows more about this than the astronauts themselves? So actually, fun fact, Sunny Williams, she's actually from Euclid, Ohio, which is right next to Cleveland. So that's pretty cool. And of course, the SpaceX Crew Dragon that just docked yesterday, yesterday to the space station. The Boeing Starliner, we're hoping, can get up there pretty soon as well. And then really quickly, just for the future engineers and scientists, I wanted to run through engineering design process that we typically follow. So these are just a series of steps you can follow in order to solve a problem or need that you have. So first, you research, find as many resources as you can, or as much information as you can about the problem or need that you have. And then from that information, you develop a design, and then build a prototype, and then test and evaluate that prototype.
Great,
And
great, great.
then, yeah.
Yeah, so that is the scientific temperament which we all should have to observe something, to test it and evaluate it, create a prototype out of it, and to actually test out the conclusions, right? So the actual scientific temperament, that is super, super useful. And now kids are just posting so many questions. They want to ask so many questions from you,
Okay.
and let's hear them out. Okay. So
Okay.
now, yeah. So now, first question, sir, I hope is this not too much philosophical, but which is, what does NASA think about aliens? I mean, I'm sure you do not say that aliens do not exist, and you don't say aliens do exist. So what does NASA think about it? Do aliens exist? What is it?
So actually, that is a question that we're trying to answer ourselves. We think that I'll start with this. We think that life did exist at one point on Mars because is evidence that water was on the surface at one point. And whenever you have surface on the planet, that is, there is a high possibility that there was life, at least at a microbial level. So, I mean, that would qualify as an alien technically, but as far as a humanoid alien, there's no proof that their aliens exist yet, but we're always looking. That's one reason we're always exploring. And that's something that hopefully your generation will discover, or future generations. So.
And another question which kids are really curious about is about black holes. What are they? As in, some say that time slows down near black hole. Some say that they can wear an antimatter shield and then go inside the black hole. Some say that there is a white hole at the opposite end of a black hole from which you can reach another universe. There are so many theories around it. So what does NASA think about that? What are black holes?
Okay, so I like this question because black holes, you see them all the time in sci-fi movies, of course. or in like just popular culture. So I guess the most basic definition of a black hole is that's a region of, I guess, time space where the gravitational pull is so strong that anything that goes into a black hole, so whether it's matter, radiation, or light, it can't escape the gravitational pull of it. So it pulls whatever comes into it. And I believe there is no concept of time while you're in the black hole. And that's one thing that one of the experiments that we're trying to study on the space station. We have equipment on the space station that's able to help us learn more every day about black holes and what's out there in space. Now, as far as the antimatter shield, I'm not exactly sure. That's more of a question for an astrophysicist, but yeah. And also one thing about black holes, I think in science fiction, we typically see black holes sucking everything in. They don't actually do that. You have to specifically aim at a black hole. So you have to deliberately aim whatever you're trying to get in there into a black hole. So you can have a planet or a moon orbit a black hole. So that's what I'm trying to say. Mhm.
Yeah.
Mhm.
Of course, Jared sir. Let's do so. Now is the time to go to the space simulator and to see for ourselves how does solar system look, how do rockets fly and everything like that.
Mhm.
So
Okay.
yeah. So give me a second till I open up that particular thing. Okay, good. Yeah. Until then, sir, there are more and more questions coming in.
Okay.
And the
Sure. Yeah.
first question is, how can these kids also join NASA? As in, what should be their path? How can they also join NASA?
Sure. So when I joined NASA, I did it through says you're trying to enter the waiting. Anyway, so I joined in an internship. That was how I first, excuse me. Yeah, so internships are a great way to join NASA. But at your age, I guess just learn as much as you can about it. And also just study, make sure you enter a field of study that you're passionate about that aligns with what NASA does. As I mentioned, we have a lot of different job opportunities at NASA. So it's not just engineering. You can be a scientist, you can be a technician, you can work in IT department. Um, they've helped me out plenty of times, honestly. And yeah, there's something for everyone at NASA. So I would just say pursue your passion, whatever you're most interested in.
Yeah, this is exactly true. Pursue your passion, keep learning, keep studying science. And as you heard from Jared, sir, he read encyclopedias. He was deeply passionate about science. He just wanted to create stuff. And that's why he went and took an internship at NASA. And subsequently, things started to add up. And now you can see what all he is doing. So great. Now comes the time of the virtual space simulator in 5 seconds. Yeah,
Mhm. Okay.
let's go. Okay, guys. Can you all see my screen? I'm sure you
Yeah, I
can.
see it.
Great. So Jared, sir, this is also your introduction towards Kalam Labs. It's
Okay.
built on a simple stuff. Kids love science. So why not help them simulate it? Why not
Mhm.
help them move through wormholes, save Earth by, save Earth from extinction by doing panspermia, or perhaps just take a spaceship and go to Kuiper Belt, right?
Mhm. Right.
Basically do everything, control this jigyasu character and keep learning. So that is just the objective of Kalam Labs. So moving in and opening up the module. Like, okay, I am super excited. I love this. I love this part of the sessions because I could actually control a spaceship, move to any place that I want to go. So back when I was a child, Jared, sir, I was an avid lover of astronomy as well. I
Okay.
used to read encyclopedias and I used to imagine myself as an explorer. So, I will also take a rocket, go to the outer space, find life, find aliens, and everything like that. So, yeah, it's really interesting.
It's
Yeah,
awesome.
yeah,
Nice.
great. Now, so wow, there's another question coming in. Wow, so there are questions regarding Perseverance and Ingenuity and Curiosity, the rovers
Okay.
that were sent to Mars.
Hmm.
And they were, and I think so. Let's ask the kids. Kids, do you know about the Artemis program of NASA? If you know, type in yes. Okay, let's see whether they know or not. Okay, until this is loading. Okay, so another question is coming, which I wanted to ask. No, so Jared, so there is a thing called dark matter,
Hmm.
right? Which kids
Right.
are really curious about, and I do not understand. What is it?
That's a good question. So, dark matter is pretty much any substance that interacts, I guess, with gravity or visible matter. So it looks like, or it's very similar to, I guess, what a black hole is. Um, Pretty much nothing, anything that enters it can't come out. So whether that's light, radiation, or matter, um, yeah, it's very similar to what a black hole is.
Okay, okay, okay.
Yeah.
So basically, dark matter can be found anywhere, right?
Right, pretty much anywhere in space. Yeah. So, and
Anywhere.
that's another thing. That's one great thing about space exploration and just having the space station. We're able to learn more and more every day about those things through the astronauts and the experiments that we do up there.
And so also wanted to learn about the multiverse theory, that there are multiple universes and they're not the only universe that we live in. Is it that is also true?
So from, I guess personally, I believe it could be true. We don't have, I guess, any evidence right now. It's more theoretical than, I guess, factual right now. But
Wow, wow, that is
mhm,
super, super cool.
yeah.
So now, in a short while, we're gonna begin. Oh, so there are some questions which you some must have always heard, which
Mhm,
is, I think so. Acha, answer this question, sir. I know right now when you have learned everything, no, you must be thinking that aliens exist, multiverse theory. These are a bit sci-fi questions, right?
mhm,
Questions which basically scientists are not spending that much time. They are spending more on time on experimenting, the scientific temperament which you were talking about, right?
mhm.
But let me ask you a personal question. When you were a child, did you also used to think about these things? Dark matter, black holes? Yes, sir.
Yeah, of course. I think any kid that's just inquisitive or curious about just what's out there, that definitely crosses their mind. So
Yeah.
it definitely came up. There's always been questions that I wonder about, and pretty much you just learn that you can learn by just Google searching
Mhm.
whatever you're interested in. So
Of
yeah,
course.
and definitely, I think any person that's, I guess, interested in space or astronomy in general, like that'll come up in their head.
Of course, of course, of
Yeah.
course, sir. Of course, of course. Yeah, so that is that. And until then, I guess so, sir. Now let's have some more questions. So now let's see what these questions are. Oh, so there is this question, and you can choose not to answer it. So
Okay.
this question states that, according to you, personal opinion, no, which is better, SpaceX or NASA?
um,
You can choose not to
well,
answer it.
I'll just say no comment with that one. But I
No
mean,
comment.
I am working at
That case,
NASA,
it's
so I mean,
SpaceX. Otherwise, you'd have just said NASA.
I'll just say this: we work together
Yeah,
collectively on a lot of different projects, like Commercial Crew. That's one
yeah,
of them. Artemis, we're going to be working together on that. So
yeah.
we're not trying to compete with each other like a lot of people think. Like
Mhm.
it's more of a collaborative
Yeah,
relationship. So yeah.
yeah, guys. And yeah, kids, I think so. Yeah, that is something which you guys need to learn too, that we should not, collaboration is all. Hello?
Yeah, I hear you.
Yeah, just a second. Yeah, here we go. Sorry, that screen had gone off. Yeah, so that is kids. I think so. That is what you could learn too. That instead of competing, instead of defeating one another and choosing one above another, we should always try to collaborate, as NASA and SpaceX have done. They're collaborating together and taking the boundaries of human race forward, right? So that is what it is. And so more questions, so the questions never end, as like that is what the curiosity is, I think so. Okay, so more questions on alien life, which is answered. Yeah, let's see. Okay, so one question is, how did it all begin? As in, how, I mean, we all know Big Bang, right? A blast occurred and everything just splintered away. But what caused the Big Bang? How do we know that Big Bang is true? What are your thoughts about it?
So the reason we know the Big Bang is true, just because we've had over centuries, we've had just astrophysicists and all kinds of scientists, even starting with Galileo, or even before him, just studying things, because humans have always been curious about things like that, how we got here, how the universe started. But I guess the simplest explanation of how, I guess I'll start with the solar system, how that started. So I guess it was 4.5 billion years ago. It was a cloud of interstellar gas and dust. It collided and resulted in what's called a solar nebula. And that solar nebula resulted in like a swirling cloud of matter. And that's basically how the sun formed and all the planets formed. And the sun's gravitational pull is so strong that all the planets rotate around it. So all 8 planets, and then you've also got the dwarf planets. But there's a much more, like astrophysicists could give a much more in-depth explanation as to what happened. But from my understanding, that's the simplest way to describe it.
Wow, this is super interesting, sir.
Mm-hmm.
And so like one question which is from me only, which is that, so like back when I was a kid, the first science project that I made was a baking soda rocket, right? I had made a baking soda rocket. It did not really work, but I made it. I put in vinegar. I put in, what all was it? I put in baking soda and vinegar. That's all that I put, right? And I put a cork over it, and it blasted. Boom. So that's what I made. And I think so kids must have made such science projects as well. And you could post it on the comment box, whatever, what was the first science project that you guys made? So that's the question that I want to ask you too. What is the first science project you made?
Sure. So I think one of the first projects I made was a Coke and Mentos rocket. So if I were like, so you mixed, you obviously just drop a bunch of Mentos in a Coke bottle and it explodes. So that was, from what I remember, that was the first rocket that I ever created. And then I know in my senior design project, we actually launched a model rocket. It went, I believe 10,000 feet in the air. And that was pretty cool. We had a GoPro on it and everything. So it's really interesting.
That's great. That's great. So, and so yesterday only I was talking to Harshit, and he discussed a science topic with me, which I wanted to share with you, which was about Incinitus. So Incinitus, I think so, is one of the Saturn's moon, right? So
I'm sorry, can you repeat? What was it?
Infinitus. He said
Okay.
Incinitus.
Oh yeah. Okay. I know what you're saying.
So
Yeah.
I'm sorry if I'm mispronouncing
That's
it.
okay.
Yeah. So this moon of Saturn, Incinitus. So Harshit was telling me that it is filled with water. That it is actually filled with water, and once a NASA probe was going close by, and it saw a water fountain come out of that particular moon. So was that all true? Like, what do you think about that?
Well, so I know that there are like 3 of Saturn's largest moons. They are believed to have water either on the surface or underneath the surface. Now, about the fountain, I hadn't heard that before, If it was, that'd be really interesting.
Wow. Wow, that is super interesting.
Mhm.
So, sir, like if there is water there, right? And if there's like a
Mhm.
moon where there is water there, so can we just go and drop a fish inside it and it will start to live?
Ideally, yes, but it all depends on the atmosphere. So Saturn is one of the gas giants. So Jupiter and Saturn are both gas giants. So they're made mostly of hydrogen and helium gases. Like that's what their atmosphere consists of. And because of that, they're actually really light, even though they're really large planets. So one thing about Earth, we have free oxygen in the atmosphere, so in the air we breathe, and also the water we drink. So that's how fish and everything are able to live. So if you drop the fish in Saturn, it would likely die just because that water is not conducive for
Oh,
living things. But in a ideal world, yes, you could, but not really. Yeah.
not an issue, sir. But so then my question is that no, why do we try to live in Mars then? As in, why don't we try to live at Enceladus? It has water.
Sure. So Mars, I guess proximity would be the obvious answer with that one. So the Mars is a lot closer than Saturn, or Enceladus, the moon. Um, but yeah, Mars, there's growing efforts to try and colonize Mars. And first, we want I guess the main driver with the Artemis missions going back to the moon is learning how to live and thrive on another world and do it sustainably. And we want to use the moon as a proving ground to travel to Mars and just learn how to live on another world. But Enceladus, I guess that would be the next step, I guess. But also, there's no solid surface on Enceladus. So as far as I know, well, actually, Saturn doesn't have a solid surface, but Enceladus, we'd have to do a lot more research on it. So
Wow, that is super interesting. So now, okay, so that is that. And recently I heard about this really cool thing, which is that NASA has flown a helicopter on Mars. They have actually flown a helicopter on Mars. How did they do that? The air is so thin. It is on another planet. There is nothing there. There are no humans. How are they flying a helicopter there?
yeah, so yeah, before I answer the question, so JPL, which is located out in California, they have engineers and scientists that are leading just the Mars Perseverance effort. But as far as Ingenuity is concerned, they developed uh, they developed rotors um, and propellers that are able to fly in, specifically designed for flight in Mars conditions. And we have just mission control people from Earth relaying signals to Ingenuity, and it was able to go on its second flight, I believe, 2 days ago. So it's really fascinating how they were able to do that because it's the first time we've flown anything like helicopter or any aircraft on another planet. So
That is super interesting, I must say. And now, so what has happened is that many of the Kalam Labs members, they have sent us videos in which they are asking the questions by themselves. So if you allow, I'll share the screen, play up their videos. Let's hear
okay.
it from them. Yeah, just a second. Let me just find them up. Give me a second. So one of the questions was basically, so all of these questions are from kids, all from Indian schools, wonderful
Mhm.
schools, Shri Ram Public School, Caloric schools, and all of there. So let's hear it from them in a short while. Let me just start it up. Okay. Give me a second.
Mhm.
I think so. You can see the screen now.
Yep. Mhm.
This is a very cute little kid. Let's hear it from her.
Hi, my name is Tanishi. I am in grade 2 and I am in Shri Ram Aravali school. My question is there always night in space? Because there is sun over there and sun makes morning. Uh, but there is, always, in videos I always see that they show night. Thank you.
This is a wonderful question.
Yeah, that's a really good question.
Of course, sir, please.
Okay, so I guess the best way to answer that is I guess on Earth, we have morning and we have night, and the sky is incredibly bright because of the Earth's atmosphere. So light is able to be scattered throughout the atmosphere, and that's why we have as much light as we do. And in space, you don't have that same, like there's no atmosphere out in space, so you don't have that same ability for light to scatter. You do have, there's a lot of stars in space, so there's light from those, and also, of course, the sun. But really, it mainly comes down to the atmosphere makeup.
Okay, so that is a very fascinating thing, because we think that days come when the sun is there, and the night comes when sun is not there. Like that's what we basically assume. However, that is not the entire case. We can only see the day when there is an atmosphere, when there is an actual air where scattering is happening, an actual place where the light is hitting and we can see it. That's why only, day is possible. Because then if you go to space, there is just vacuum and you will see nothing. There is no particle at which light is falling upon which you can see. So this is really fascinating, sir. Like all of the assumptions that we learn as a child, they're broken by pure science.
Right, yeah.
Cool. Let's hear another things. I'm really happy to share another one. Just give me a second. Yes.
Hello, my name is Anayata Kaur Khurana and I'm 8 years old. And today my question for you was, if we ever go to the planet Mars, how are we going to produce mass oxygen for us to breathe?
These are the questions NASA is grappling with. So
Yeah.
answer that.
Okay, so I believe the question was, how are we going to produce oxygen? Is that right? Yeah. So that's a really good question, because Mars is mostly made of, its atmosphere is mostly composed of carbon dioxide and very trace amounts of oxygen. So pretty much we have to take oxygen with us. Like that's how we, yeah. And we also have, there's a project we're working on. I can't discuss it too much, but it's the ISRU project, ISRU, and we're working on just making usable, I guess, resources out of what's available on Mars. That's as much as I can get into it right now, but yeah, we're looking into all kinds of ways that we can do that. So it's a really good question.
So, sir, did you almost shared with us a secret mission of NASA?
I might have.
Wow, this must be so interesting. This is so interesting. I'm loving this. No, so just let's have another question from them. Okay. So I think so. This is a great kid. Let's hear it from him.
Hello, my name is Vedant Kumar and I'm from Delhi, India. My question is regarding about a device called Dyson Sphere. I've been hearing about a device called Dyson Sphere, which you basically use to engage the sun and harvest all of its energy. I'm just wondering, how does it use the power? Like, how does it transfer all of the power from the Dyson Sphere to Earth to use for like lights and different things?
Yes, sir.
So that's a good question. That's kind of out of my area of expertise, but I guess the question was, how can we use that light as energy? How can we harness it? Is that what basically the question was?
Yeah, yeah.
Yeah, so it's a very interesting concept. Like I said, it's outside of my area. of expertise, but I believe that, I mean, you could probably only take a fraction of that power because, I mean, stars are what, giant balls of hot gas. So I would think you'd only be able to take like a fraction of that power and actually harness it. So it's very interesting. It's probably something that we're looking into right now.
Great, great, great. So Dyson Sphere and that all like a type 3 civilization, right, sir? That's a type 3, right? If I have it correctly.
Right. Yep. Mm-hmm.
Wow, type 3. So this kid has his eyes set for the type 3 civilization. And here we are thinking upon, never mind. Let's have another question. So this is, yeah. Just a
Hello,
second, let me
sir.
share.
My name is.
Mm-hmm.
Yeah.
Hello, sir. My name is Kalam Labs, and I have a question for you. Did you discover why there is a hexagon shape on Saturn's poles? Thank you.
So that's a good question. So I believe that, okay, so the hexagonal shape on Saturn's poles, I would imagine that it's probably due to some kind of storm, because if you recall, Jupiter has a great red spot, and that's just a storm that's been raging for centuries, like hundreds of years. So pretty much any shape that you see like that, any distinguishable shape, it'll be caused by a storm or some kind of phenomenon on that planet.
So that hexagon on the top of Saturn, that is made by a storm?
That's what I would imagine, because honestly, I'm not too familiar with that, but yeah, that's what I would speculate. That's what it would be caused by. Yeah.
That is super interesting. That is super interesting.
I'll definitely encourage do more research on it, because it's a really good question. Yeah.
Of course, that is a really great question.
Mm-hmm.
Yeah, just a second. No, so let's have another, just the last question. Like this kid really insisted that it needs to be played. I understand he must be really busy, but no, they were really insisting upon it. Yeah.
Okay.
Just a second. Yeah. Oh, that's Samira. Okay, let's have the question from Samira.
Hello, Jarreds sir. My name is Samira. I'm from India, and today I want to ask you, what researches are you doing in NASA these days?
So what resources are we doing? So what projects we're working on?
Yes, sir. What researches you are doing? What are the new inventions you are focused towards?
Okay, so missions, got it. Okay, so obviously Artemis, that's the biggest mission that we're working on right now, trying to get the next man and first woman to Mars. We're working on a lot of projects that are being flown on the International Space Station. There's a lot of experiments being done there. And also in terms of aeronautics, just working on not only just typical jet engines, but hybrid electric or all electric aircraft. And also just planetary science, so studying more about our planet here on Earth, like learning more about what's going on our planet and just other planets in general. So pretty much all kinds of projects we're working on. It's a really good question.
Great, 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 sir. And now let's move towards the science simulator, which kids were asking about, and let's spend some time there, sir.
Okay.
Okay, so this is it, sir. Our humble little solar system,
Nice.
where you can see the entire Mercury moving around, where you can actually see, Saturn with asteroids and everything there. So just a couple of questions regarding this, sir, which is that now one basic question which I always had in my head was, Why is it that all of the planets that we see, which are to the closer side of the asteroid, like Earth, Mercury, Venus, Mars, they're all rocky. Whereas if you think about Jupiter, Saturn, Uranus, they're all gaseous giant. So why is that? Is that a coincidence, or there's some science behind it?
Um, yeah, it's a good question. So, yeah, as you said, the first four planets are the rocky surfaces, and I just believe that's just due to how they were formed, honestly. And I think probably proximity to the sun, um, that plays a big role as well. But you look at Uranus and Neptune; those are farther away from the sun, so it's a higher likelihood that those will have more ice than the other planets because it's just because of how far they are from the sun.
Wow, wow, that
Mhm.
is super cool. And so just a few more questions apart from that. And I'm sure as kids are also must be having a lot of questions. So just a few more questions. One is about our famous Artemis program. Like I'm sure many kids might like if you can explain Artemis program to kids and tell what is NASA exactly aiming towards, we would love to hear that.
Okay, sure. So we're aiming to put astronauts back on the moon. 2024 is the year that we're looking to do that. And it's going to be, but even before that, we're going to embark on a 10-day mission where we just we use the Orion spacecraft to send astronauts to the moon, but just to circle it and then come back, just to prove like that it can actually complete the mission. And in 2024, that's when we'll ultimately put astronauts back on the moon. So,
Wow.
yeah.
Basically, more Neil Armstrongs are coming in, and at 2024, we are going to reach the moon. So when are we going to set up a lunar base there?
Hopefully within probably within the first 2 or 4 years of landing on the moon. So that's another project we have called Gateway, which is basically going to be the space station that orbits the moon. And that will help us to establish that sustainable presence on the moon. So not just going there just to say we went there, but to go there and just have a presence there, start developing lunar base and landers that we can use and reuse.
Wow, that is super interesting, sir. That is super interesting. And thank you so much for coming here. Thank you
Sure.
so much for sharing your knowledge with kids and making it super simple for us. I mean, I'm sure kids absolutely loved it. Each of the kids that we interact with here at Kalam Labs, they would love to go to NASA and be where you are right now. So it's really superb to see and actually interact with you. So that is really interesting, sir. And if you would like to just share some thoughts of yours towards India's space potential, about your thoughts, anything, sir, would love to hear that.
Sure. So first of all, thank you again for having me. I really enjoyed talking with all of you. As I said, hopefully you can rewatch this presentation and see just all the resources available for you to learn more about NASA. The ISRO, they're doing really exciting things. I know NASA and ISRO, we're teaming up. Well, JPL is leading it, but the two organizations they're teaming up on what's called NISAR, and that's going to be just I guess, a satellite that orbits the Earth. We're going to find out more about Earth's geology than we ever have before, and in terms of biomass and things like that. And I know that ISRO, they also launched the first, or they were, I believe, the first. So India was the first Asian country to launch a Mars orbiter vehicle. So I thought that was really interesting, and the fourth nation in the world to do so. And that was done, I think, in 2015. I might be wrong on the year, but yeah, India is doing a lot of really interesting things. And I think that Mars orbiter, that was the most cost-effective one that was ever developed. So yeah, it's really interesting.
Yeah, of course. Like it's super interesting to talk to you. And the curious kids of Kalam Labs just absolutely loved asking questions from you, and they were pinching us for like one entire week. Jared sir is coming in. I'm going to ask him whether aliens are real or not. I'm going to ask him whether, how did the rover flew, how did the helicopter flew on the Mars, and every particular stuff like that. And now all of this I have been answered. So it's really wonderful to have you here, sir. Thank you so much.
Yeah, thank you. Thank you.
Thank you, sir.
It's great to be here.
Okay. Thank you, sir. Thank you so much, sir.
Mhm.
So guys, that was yeah. So that was it from Jared sir, and I'm sure you must have really loved it. If you want to ask more science questions, post it on right now, and I'm still here. So let's do it. Come on, post it on the chat box. Who can post most science questions on the chat box? Let's have it. Okay, so now, brilliant questions are coming in at such a fast space. Okay, so yeah. Okay, so first of all, the biggest question that I see right now is, yeah, how do black holes move? What will happen if we travel at the speed of light? What will, how fast do black holes move? Is there any the planet discovered by NASA? Is there internet on space? Is there, who is your most inspirational person? How do extraterrestrial animals look? So, kids, these are the wonderful science questions that we answer every day at Kalam Labs. Every day at Kalam Labs, these are the science questions which we always answer. So now, if you are also excited about it, if you are also excited to learn more about science and be the kind of aerospace engineer, astronauts, scientists like we see here, there at NASA, or perhaps at ISRO, or perhaps at ESA, European Space Agency, or perhaps open up your own company like SpaceX. So basically, any scientific pursuit that you want to follow needs to be built on scientific knowledge, actual knowledge, which we will build up. Then only we will create the next spacefaring community and the next spacefaring community from India. So now I talk in Hindi, okay? Because because for the next coming decades, it is Indians only which would be beginning up, which would be creating the next wave of innovations, and together we will do it. So now I'm super happy to interact with all of you, to learn from all of you, to answer your questions, to be a jigyasu with you. Okay, so if you want to continue learning from Kalam Labs, if you want to continue viewing such particular sessions, if you want to personally interact with scientists, learn more from them, there is a link in the description of joining Kalam Labs. Talk to your parents. If they find it useful, join Kalam Labs, learn science, and be the kind of jigyasu which you can. Okay, I have answers to each and every question which are being posted there. Each and every question, have it there, have it in front of you. And above all, as you all know, our virtual space simulator, have it on your phone. Have all of the Kalam Labs, the entire virtual space simulator right on your phone by joining it. So I'm sure this must be super interesting for you. Next Sunday, we are going to come again. We are going to talk again, and we are going to learn a lot about science. So join Kalam Labs and join it today. Okay. So great. And as the people who have already joined Kalam Labs, when we end any session, we always say one thing, and that is, we love science. So now at the chat box, if you love science, if you are excited about it, type in the chat box, we love science. We love science. Come on, everybody. Type it in the chat box. We love science, because that is something we all do. Okay, we love science. Okay, so now this is the particular thing which we do every time. And now if you want to know who is coming next week, if you want to download the game, join in at Kalam Labs and see for yourself. Okay. So never, 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 never. So yeah. So great. So now we have had such a wonderful session. We Love Science OP has begun. We love Science OP. We love Science OP. I also love Science OP. Overpowered. We love science. We love science like we love Dr. Binox. We love science. Okay. We love science. This is super, super, super interesting. Wow, I'm sure you guys must have had a lot of fun. We love science. Wow, everybody is typing in we love science. Yeah, we love science. OP, I also love science. Yeah, we are going to be the spacefaring community and build civilizations on Mars because we love science. Wow, we love science. Wonderful to see the passion in all of you. Okay, we love science. Great, 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 great. Now, guys, join up Kalam Labs so that we could interact in real time, learn from each other. Okay. Okay, guys. Great, great, wonderful session with all of you, man. Wonderful session. We love science. Okay. Link in the description. Let's have it. Okay, great. We love science. OP. Oh my God. So much. It's still going on. We love science. We love science. I also love science. Yeah, great, 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 great. We love science. Wow. So if you still have questions, if you still have science questions, type in yes in the chat box. And we assure you that at Kalam Labs, all of your science questions would be answered. If we also don't know the answer, then we'll find the answer together. Okay. So if you also love science, if you want to basically keep having your questions answered, join Kalam Labs. Great, great, great. So that is what we do here. Loving it, loving it. Is there end of universe? Wow, wonderful questions. Wow, we love science is still going on. We love science OP. We love science OP. Yeah, we love science. Great. Wonderful to have such an engaging audience. Jarreds was also really, really enthusiastic to talk to you. All of the questions by cute kids like Samara and everyone was really interesting and really, oh, the yes, 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 of course. That is super good. Wow. Keep typing in yes, keep typing in yes. And because we also have questions in our heads, keep them asking, keep your scientific curiosity, keep your jigyasu inside of you alive, because when we get big, when we grow old, we are going to go to space. We are going to build up, India is going to build up the next NASA. We are going to actually, basically colonize Mars, move to other planets, like basically start civilization at Incinitus, which is a Saturn's moon, and love it. Okay. So now, great. So guys, really wonderful to interact with you. Okay, great. Now, okay then, great, great, great. So now, guys, we all love science OP. Oh my God. Okay, okay, okay. So now, kids, if you want some of your science questions to be answered, if there was some science questions not answered, okay, join Kalam Labs and we'll interact again. Okay? Okay, got it, got it. OP. Overpowered. Great, great. Wonderful interacting with you. If you also want the Kalam Labs virtual space simulator, link in the description. Bye-bye. Bye, everyone. Bye. Bye. Bye, everyone. We love science. India is best. Have a nice day. Stay safe, everyone. COVID is raging, but